We are going on with circle geometry and we have 4 questions to answer. Our first question is find 3 angles equal to x. Next, we want to determine the size of angle OSR. We are going to find angle O2 in terms of x. And then lastly, determine the value of x. Before we answer these questions, let us read the information that we have. We have that POQ is the diameter of the circle, that O is the center of the circle, the line TSR is a tangent to the circle at point S, and the lines QS, OQ, and QR are equal. So we have QS, OQ, and QR as equal, and they are indicated as equal as well on the diagram. Lastly, we have QRS is equal to x. Our first question is to find 3 angles equal to x. When I inspect the diagram, I see that one of the arms that form the angle of x is equal to QS. So we have QR and QS equal. And this shape is an isosceles triangle. That will make angle S4 also equal to x. But we don't say isosceles triangle, we say angles opposite equal sides. For our second angle equal to x, we would use S4, and we can see that the angle of S4 is the angle between a tangent and a chord. And from the tan chord theorem, we know that that angle is equal to the angle formed at the circumference. So that means that angle P would also be equal to x. And our reason would be tan chord theorem. And if I inspect the position of the angle P, I see that one of the arms of the angle P is a radius, because we have the line from the center to the circumference. And we also know that the line OS is also a radius. So OP is equal to OS. And because they are equal, it forms an isosceles triangle. And that will make angle S2 also equal to x. So what we can say is that angle S2 is equal to x. And instead of saying angles opposite equal sides, we can say angles opposite radii, because we know that OP is equal to OS. The second question says, determine the size of angle OSR. So from O to S to R, we see that there's an angle formed between the tangent of the circle and the radius of the circle. And we know that that angle would be equal to 90 degrees. So we say angle OSR is equal to 90 degrees, and our reason is that the tangent is perpendicular to the radius of the circle. The third question says, determine the size of O2 in terms of x. Now if I look at the position of O2, I see that that's the angle formed at the center of the circle. And what we know is that the angle at the center of the circle is twice the size of the angle at the circumference of the circle. So on this diagram, the angle at the circumference is angle P, and we can see that the angle at the center is O2. And we already have P equal to x. So we would say O2 is equal to 2x, and our reason is angle at the center is equal to 2 times the angle at the circumference. And our last question is to determine the value of x. So with the information given that QS, OQ, and QR are equal, we have formed an isosceles triangle in triangle OQS. But what we also know is that the line OQ is equal to the line OS, because they both are radii. So we have OQ is equal to OS radii, but we also have QS equal to OQ. Therefore, all three sides of that triangle are equal. So we have an equilateral triangle, and we know that the interior angles of an isosceles triangle is equal to 60 degrees. Therefore, the angle O2 would be equal to 60 degrees, and now we can say properties of an equilateral triangle. That will make 2x equal to 60 degrees, and therefore x is 30 degrees.